Today we talked about finding regression formulas for sets of data. So far we've done linear regression, but not every relationship between information is going to be linear. So that's what we're going to talk about today. We're going to do number 15, which is actually a part of your homework. So you get one kind of done for you. You'll have to write down the answers, but we'll do this together. When I'm looking at this table, just looking at the information, as my months go up, so January, let's let that represent 1, February 2, March 3, and so on. As my months go up, notice how the precipitation actually drops, and then it increases again. So obviously this is not Florida, or else we'd have basically the opposite happening. So already I can look at this and say it's not linear. So I'm not even going to try and make a linear equation fit this data. But I do need something like a quadratic. And so what I'm going to do is show you how to put that into the calculator. So we're going to go to the graphing calculator here and walk you through how to do this. So first I'm going to turn this guy on, clear this out, and I'm going to go to this where I have my stat plot. So go to second, stat plot. And you notice that right now I've got my stat plot on. That is good. If it's off right now for you, then you need to turn it on. So once I do that, then what I'm going to do is I'm going to edit my list. So I have a list from another practice problem we did in class today. So I'm going to have to change this, okay? So once I go to stat, I'm going to go to the edit portion. So I'm going to hit 1, enter for edit. And as you see, I already have some data in here from the last problem. So I'm going to clear this out. So just hit clear, enter, go over here, clear, and enter. And once I clear out that data, then I can add the things I had in my table onto my graphing calculator. So let's just bring this guy over here. So I've got them right next to each other. Maybe you can see that way. So I have 12 months. So I'm going to put those in as my X values. So I've got 1, 2, 3, 4, and 12, okay? And then I'm going to go over to my L2, my list 2, and that's where I'm going to put in the precipitation information, okay? So looking at this, I've got 4.45, 4.01, 3.26, 1.17, 0.38, 0.11, 0.03, 0.07, 0.2, 1.4, 2.49, 2.89. All right, that's everything. So now that I've got my list, this is where we really start making the magic happen. We go to stat. We're going to go over to calculate. So go over to calc. Before we did this one, number 4, the linear regression, we already looked at the data, said, nope, this is not going to be aligned. So I'm going to go to quadratic regression. So this is me kind of assuming that I've got a quadratic function going on. So I'm going to hit enter for that. I am in fact using list 1 and list 2. And if you don't have the plus addition, you're going to have to put in the second L1 comma second L2. And then where it says store regression equation, this is where I'm going to do the vars to this. Remember that, guys? So vars, and go over to my function, and I'm going to pick where I want to plot this. I'm going to plot it in Y1. And so if you don't have the plus addition, you'll have to, after you have your L2, put comma, vars, and then do the same thing, Y1. All right, so now we're going to go ahead and calculate this guy out. Okay, when it calculates, I get an R-squared value, and I see that that is really close to 1. So that should tell me that I've got a good fit. So now that I've got that, I actually we'll take a look at my stat plot. Before I do that, I'm going to take a look at my actual line here. So it's written in the standard form, ax squared plus bx plus c, and I'm given the coefficients for x squared, x, and then my last constant. You can go ahead and round to the nearest thousandth. That's okay. So in this case, I get 0.132 x squared minus 1.893x plus 6.847. That would be the equation for the parabola. Okay. Now I'm going to actually go to my plot. Now the plot may be a little messy because I have, I think, another line in here where I had y2. And when I go to my plot immediately, I've got the linear regression from the last plot. So what I'm going to do is go in here, and you don't need to do this unless, of course, you were in class today and you plotted the regression in y2. Remember when we did that? So go ahead and clear that out. Now I'm going to go back to my graph. There's nothing there. It looks like a weird line. Okay, so what do? I need to go to zoom and head down to zoom stat, or just hit 9 and enter. Okay, there we go. Now I've got my points and I've got my regression best fit line, which is quadratic. So we see there are some points that are going to be off, but for the most part, this fits the data, which is a good thing. That's what we want to see. So that's basically how we put that on a graphing calculator. Just to show you one more quick thing here, if I happened to not recognize from the table immediately that it was not linear, let's just say I said, I want to figure out a linear regression for this. What you do is you go to calculate, go to your linear regression, okay, and put in your information, L1 and L2, calculate it out. Look at your R squared value. What do you notice? Well, it's not even close to 1, right? Or -1. So that means we have a bad fit. Remember we talked about how R squared closer to -1 or 1 means it's a better fit. So in this case, this is a bad fit. So if I didn't recognize it from the table, I could always just do the linear regression and look at my R squared value. If it's bad, it's not linear regression. So you're going to continue this on numbers 16 and 17, determining whether it's a linear regression or quadratic, and find the equation. All right, good luck, and I'll see you in class.